live.
Okay. Very good afternoon to all. Myself, Vaishali Patel, Assistant Professor, Faculty of Pharmacy, Parul Institute of Pharmacy and Research, Parul University. I take this pleasure to welcome Dr. R.K. Maheshwari, Professor, Pharmacy Department, Sri GS Institute of Technology and Science, Indore, Madhya Pradesh, from today's webinar on eco-friendly techniques using hydrotropy, mixed hydrotropy, and mixed solvency concept. Dr. Maheshwari has 33 years of teaching and research experience. Sir has completed his B.Pharm and M.Pharm from Dr. H.S. Gaur University, Sagar, and PhD from School of Pharmacy, Indore. His expert field of research are hydrotropic solubilizations, mixed hydrotropic solubilizations, mixed solvency concept. He has published 189 research and review papers and reputed national and international journals and filed 3 Indian patents. He has presented more than 150 paper and international and national and state level conferences and received several awards. Sir has guided 72 PG students to PhD students and 1 student for university under his supervision. He has published around 6 books in his credit and delivered more than 200 expert lectures. Now, with these introductions, I request Dr. R.K. Maheshwari to start this webinar. Sir.
Okay. Thank you, madam. Thank you for nice introduction.
Thank you, sir.
Firstly, I would like to thank the management system who has given me this chance to deliver the lecture. As you know, the topic of today's lecture is eco-friendly techniques using hydrotropy, mixed hydrotropy, and mixed solvency concept. What you shall get in my lecture, that we can utilize the solubilizing power of solids to replace harmful organic solvent in analysis field, in extraction, in formulation, and of course in so many fields we can use the solubilizing power of solids. I have started a very new concept known as mixed solvency concept. First time in the world in year 2009. And there are 2 parameters of that mixed solvency concept. Number 1 parameter says that each and everything present in this universe has got solubilizing power. Each and everything means whatever the number of molecules they are present in this universe, whether they are in gaseous state or they are in solid state or they are in liquid state, all molecules possess solubilizing power. But only thing is, for gases and solids to act as solvent, the molecules of gas or molecules of solids should be in liquid state. For example, for gases, we know supercritical flow technology in which liquefied CO2 is used as solvent to carry out the functions. So the molecules of CO2, they are in liquid state and they are involved in hydrogen bonding and weak van der Waals forces with the molecules of solutes for their dissolution. In case of solids, mostly you will find the examples of solids which can be utilized to remove or to minimize the use of harmful organic solvents. Only thing, how the solids will demonstrate their solubilizing power is the molecules of solids should be in liquid state. The molecules of solid and liquid state, how they can come in liquid state? There are 3 ways by which the solid molecules can come in liquid state. Number 1, by melting. If you melt a solid, the melted solid in liquid state will act as solvent. Of course, actually, I have got very limited time today, 1 hour only. So I cannot give so many examples. In short, I can say that if you melt any solid, it can demonstrate its solubilizing power. Number 2, the molecules of a solid may come in a liquid state if you dissolve it in a particular solvent. So mostly hydrotropic solubilization, which we are going to deal with in my lecture, we will have a large number of examples of hydrotrophic solubilization. They all come under this category only, that if you dissolve a solid in a liquid, the molecules come in liquid state, and these molecules can demonstrate their solubilizing power due to hydrogen bonding and whatever forces with the molecules of solutes for their dissolution. Number 3rd way by which the molecules of a solid may come in liquid state is by eutectic formation. For example, methyl thymol, if we take in equal proportion, we try it, we get a liquid, eutectic liquid. And the molecules of methyl and thymol, they are in liquid state. And of course, so many compounds, they are nicely dissolved by this eutectic Only thing will be how to utilize the solids for their solubilizing power. So since my lecture, in my lecture you will find that how can we minimize the use of powerful organic solvent. So before that, we should know some of the organic solvent, means the use of organic solvents in pharmacy. Various organic solvents are employed in various analytical techniques like TLC, HPTLC, HPLC, UV spectrophotometry, titrimetry, etc. Also, organic solvents are involved in extraction of active constituents from herbal powder. Also, organic solvents are involved in synthesis of organic compounds. Also, organic solvents they are involved in formulation of pharmaceutical. Also, organic solvents are involved in identification and test of drugs. So, in so many fields, we find the use of organic solvent. Now, we should learn what is dissolution, what happens in dissolution. So, very simple theory of dissolution. Dissolution of a solute in a solvent involve hydrogen bonding and weak van der Waals forces between the molecules of solute and molecules of solvent. Very simple theory of dissolution. What happens? Say, for example, if you are dissolving, say, for example, metformin hydrochloride in water, you get a clear solution. Why you are getting a clear solution? The reason is there is a hydrogen bonding and weak van der Waals forces between the molecules of metformin hydrochloride and water. So there is a dissolution. If you are dissolving, say, for example, ibuprofen in ethanol, you are getting a clear solution. What is the reason for getting this clear solution? So the same reason, hydrogen bonding weak van der Waals forces between the molecules of ibuprofen and molecules of ethanol. So very simple theory of dissolution. In the same way, you will find that the solid molecules, when they are in liquid state, they can also be involved in hydrogen bonding and weak van der Waals forces with other solutes for their dissolution. Anyway, now I am reading from your slide, mixed solvency concept proposed by me in the year 2009. It states that each and every substance, whether the substance is gas, whether the substance is liquid, whether the substance is solid, present in this universe has got solubilizing power. So, in other words, in simple words, you may say whatever the molecules are present in this universe, all molecules possess solubilizing power, because all molecules, when they are in liquid state, may be involved in hydrogen and weak van der Waals forces with the molecules of solutes for their dissolution. Once the molecules of a gas or the molecules of solid come in liquid state, they may also be involved in hydrogen bonding and weak van der Waals forces with the molecules of solute for the dissolution of that particular solute. Now, about the solvent, whatever matter, up to this time, what do we know? Whatever the matter exists in liquid state at room temperature, they all are known as solvent. For example, water, ethanol, methanol, chloroform, PG 400, glycerin, propylene glycol, etc. So, whatever the substances which are present in liquid state at room temperature, they all are known as solvent. Okay. Now, each liquid or the so-called solvent possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. This thing you should mind it well. Whatever the name of any solvent you take, whether it is water, you know that 1/3 of the they are water soluble, 2/3 they are water soluble. Means there is no universal solvent. You say DMSO, it is also good solvent for so many compounds, but not good solvent for each and every compound. In the same way, in my mixed solvency concept, whatever the molecules are there, they all are known as, all substances are known as solubilizers. Only thing will be they will be having good solubilizing power for some solutes and bad solubilizing power for other solutes, just like solvent. So similarly, each matter, liquid, gas, or solid, is known as solubilizer in mixed solvency concept. Molecules of all solids in liquid state and molecules of all gases in liquid state also possess good solubilizing power for some solutes and bad solubilizing power for other solutes. Now, directly, of course, you say there are three categories of solvents. Class 1 organic solvents includes benzene, carbon tetrachloride, etc. They are very harmful. Class 2 organic solvent commonly employed, they include chloroform, methanol, DMSO, DMF, etc. Okay, toluene, etc. Class 3 organic solvents, they are relatively safer. Ethanol, you will say this acetone. These are the commonly employed class 3 organic solvents. You can potentiate the solvent power of class 3 organic solvent to act as class 2 or class 1 organic solvent also. Very limited time to explain things in detail, but Now, the drawbacks of if a human being, if they are exposed for exposure, you will say vomiting, etc. These are the drawbacks. But solving the cause of you will say the hepatic toxicity, kidney toxicity, neurosis, etc., etc. So now the aim of this particular this lecture is how can we minimize the use of these harmful organic solvents, class 2, class 1 organic solvents. How can we minimize these use? So for that, now I will discuss various examples which how can you utilize the solubilizing power of economic and safe solids. So now in this case, now firstly I would like to describe the hydrotrophic solubilization. Hydrotrophic solubilization is about 100 years old concept, about 100 years old concept. And what is that hydrotrophic solubilization? I will give firstly some examples. For example, you see the solubility of dichloronic sodium in water is about 1.6%. 1.6% dichloronic sodium solubility in water at room temperature. If you imply 60% weight by volume solution of urea in water, in this concentrated solution of urea, 60% weight by volume, the solubility of dichloronic sodium is about 4.8%, 4.8. In water, 1.6. 4.8 divided by 1.6, 3-fold enhancement in solubility there. This is one example of hydrotrophic solubilization. Urea is one of the hydrotrophic agents. Another example, the solubility of salicylic acid in water at room temperature is about 0.3% weight by volume. 0.3% weight by volume at room temperature. Okay, now if you prepare a concentrated solution of sodium citrate, 45% weight by volume solution. In this concentrated solution of sodium citrate, the solubility of salicylic acid is more than 15, more than 15% solubility. So 15 divided by 0.3, about 50-fold enhancement in solubility. Here, sodium citrate is also a hydrotrophic agent, and this phenomena is hydrotrophic solubilization phenomena. Another example, if you prepare a concentrated solution of sodium benzoate in water, say for example 25%, 30%, 35% weight by volume, these concentrated solutions of sodium benzoate increases the solubility of a large number of poorly water soluble drugs like that of ofloxacin, gadifloxacin, norfloxacin, ornidazole, indazole, naproxen, flurbiprofen, ibuprofen, atenolol, aceclofenac, etc., etc. All these are the examples of hydrotrophic solubilization. As you know this term hydrotrophic, hydro means water. Hydrotrophic solubilization with solubility enhancement in aqueous solutions, in water or in aqueous solutions. Okay, it does not include solubility enhancement in propylene glycol, solubility enhancement in ethanol, no, only in water or aqueous solutions. So now the definition of hydrotrophic solubilization, as you are seeing on your screen, these are some of the hydrotrophic agents. Now the definition of hydrotrophic solubilization, when there is enhancement in aqueous solubility, you will have to use the word aqueous solubility. So again I am repeating, when there is enhancement in aqueous solubility of a poorly water soluble drug, the presence of a large concentration of an agent means hydrotrophic agent, then we call this phenomena to be hydrotrophic solubilization phenomena. So this is hydrotrophic solubilization. Again I am repeating, when there is enhancement in aqueous solubility of a poorly water soluble drug in the presence of a large concentration of an agent, then we call this phenomena to be hydrotrophic solubilization phenomena. Okay, now I will give the examples. How can we utilize hydrotrophic solutions to minimize the use of organic solvents, harmful organic solvents? Now, firstly, I will discuss eco-friendly trichromatic analysis of poorly water soluble drugs using hydrotrophic solubilization technique without the involvement of organic solvents. So, first example is that of furosemide drug. Furosemide API, furosemide also it is known as. So how its API means bulk drug. how it's a bulk drug is estimated by Indian pharmacopoeia method or British pharmacopoeia method. Methods are same. It include weigh accurately about 0.5 gram fusamide API, dissolve in 40 ml of DMF, dimethylformamide. DMF means dimethylformamide, which is a class 2 organic solvent. When you get a clear solution, then few drops of bromothiamine blue indicator is added, and they are added, and titration is performed with 0.1 molar NaOH solution. Suppose the reading is V1 ml in this particular titration, and the point comes at V1 ml of 0.1 molar NaOH solution. Then you will have to carry out a blank determination. How this blank determination is performed? You will take a neat and clean another conical flask. You will keep 40 ml of dimethylformamide in this, few drops of bromothiamine blue indicator, and then you will run 0.1 molar NaOH solution to get in the point. Here only few ml of 1 or half ml or 1.5 ml, very small volume is needed for color change, means for endpoint. So suppose here the reading of 0.1 molar NaOH is x1 ml, x1 ml. Okay. So this x1 ml has been consumed by 40 ml of dimethylformamide. So this will be subtracted from the original volume V1 ml. So V1 minus x1. So this much volume of NaOH solution has been required for your task. Then using the factor at the end of your this slide, 1 ml of 0.1 molar NaOH is equivalent to 33.07 milligram fusamide. Using this factor of pharmacopoeia, you can find out the percent purity of your API. So what is happening here? This dimethylformamide is a class 2 organic solvent. My pharmacopoeia has utilized DMF because your drug is water insoluble, so water could not be utilized for titration analysis. Okay, number one. Number two, ethanol is a class 3 relatively safer organic solvent, but it could also not be employed. Why? Because fusamide is sparingly soluble in ethanol, or you may say in other words, it has got limited solubility in ethanol. That's why ethanol could have not been employed by the pharmacopoeia. Otherwise, ethanol is safer than dimethylformamide. Okay, so because of good solubility in DMF, pharmacopoeia they have employed DMF for its dissolution, fusamide dissolution, and then titration. Like this. Okay, now I will tell you, without the use of this dimethylformamide, we can perform the same kinematic analysis. So how means what we call the green chemistry. Now you see this hydrotropy method, means now here we will start the utilization of solids for their solubilizing power to replace harmful organic solvent. Now weigh accurately about 0.5 gram fusamide API, dissolve in 40 ml of 30% weight by volume sodium benzoate solution, aqueous solution, which is a hydrotrophic solution. You will get a clear solution. Then you add few drops of bromothiamine blue indicator and run 0.1 molar NaOH from the butane. As soon as you get the end point, you have to note down the volume of NaOH required. Suppose this is x2 ml, sorry, V2 ml. It is V2 ml of NaOH. Now you will have to carry out a blank determination as we have discussed in previous case also, in case of dimethylformamide. Now a neat and clean conical flask, 40 ml of this sodium benzoate solution, 30% weight by volume, few drops of bromothiamine blue indicator, 0.1 molar NaOH for titration. As soon as you get the end point, you will have to note down the volume, which few ml of NaOH is required for this for color change. So this X, so suppose the reading of NaOH is x2 ml. So this x2 ml has been consumed by 40 ml of sodium benzoate solution. So this will be subtracted from V2 ml. So V2 minus x2, this much volume of NaOH has been required for your drug. So using the same factor of pharmacopoeia, 1 ml of 0.1 molar NaOH is equivalent to 33.07 milligram of fusamide. You can find out the purity of the compound of your API fusamide. Now, what is the beauty of this method? what you are going to imply? You are implying a solution, aqueous solution of a solid, sodium benzoate. Okay, it is not good, means sodium benzoate is not volatile also, it is not harmful. And the cost of 30% weight by volume sodium benzoate solution is about rupees 40 per liter. Rupees 40 per liter. Otherwise, the cost of this ethanol, dimethyl formate, chloroform, etc., it is about 200, 250, 300 rupees per liter and so on and so forth. So not only your method is economic, main thing is that the human being, they are prevented against the exposure of the fumes of dimethyl formate, which is a class 2 harmful organic solvent. So in this way, what we are getting here, that sodium benzoate solution, aqueous solution, means a hydrotrophic solution, is being employed to replace a class 2 organic solvent DMF. And with 100% accuracy, you get the result. And of course, the same method, I got it checked in IPC Ghaziabad, Indian Pharmacopoeia Commission Ghaziabad, from their IP comes. So in front of me, their analyst, they analyzed by pharmacopoeia method and by this method. I mean, just I am saying the very same results were there. So what I want to tell you, what you have done here, you have replaced a class 2 organic solvent by aqueous hydrotrophic solution of sodium benzoate, which is safe and of course it is economic as well. Now, in the same way, just in the same pattern, these drugs have been, means bulk drugs, and of course their tablets also, they have been estimated by hydrotrophic solubilization technique. Chloroibuprofen, it involves, the pharmacopoeia method involves ethanol. Ethanol has been replaced by sodium benzoate solution. Naproxen, it involves methanol in pharmacopoeia. In titanium analysis, methanol has been replaced by sodium benzoate solution in the same way. Salicylic acid, ethanol, which is required in a pharmacopoeia, has been replaced by sodium citrate hydrotrophic solution. Sodium citrate solution, 30% weight by volume. Ketoprofen involves the use of ethanol in IPBP method. Ethanol has been replaced by sodium benzoate solution. Ibuprofen involves the use of ethanol. Ethanol has been replaced by sodium benzoate solution in the same way. One more example I would like to go in little bit detail, that is that of ibuprofen tablet. Ibuprofen tablets, pharmacopoeia method, IPBP method, involves the use of chloroform, which is a class 2 organic solvent, and ethanol, which is a class 3 organic solvent. What is done? They take the powder of tablet, it is extracted with chloroform, because chloroform is good solvent for ibuprofen. Then chloroform is removed in air current, and when residue remains, that is redissolved in ethanol, and then titration is performed. Very briefly, I am explaining it to you. So there is involvement of 2 organic solvent, chloroform class 2 and ethanol class 1. Now I will tell you how can you replace the 2 organic solvent. So just by use of sodium benzoate solution, you can replace this both. Just you have to shake for 10 minutes briskly with 30% weight by volume sodium benzoate solution. During this 10 minutes shaking, the ibuprofen present in the tablet powder goes in solution, and then you perform the titration. So there is no involvement of chloroform, no involvement of ethanol. Without any organic solvent, you are going to titrate the ibuprofen tablets for its content to find out its drug content. Okay. One more thing, please note down your question. As soon as some doubt comes to your mind, please note down your question. At the end of the lecture, I will give the answer of your question. Now, after TLC, after the stoichiometric analysis, now coming to UV spectrophotometric estimations of pharmaceutical dosage forms of poorly water soluble drug using hydrotrophic solutions without the involvement of organic solvents. Now, example is that of tindrazole tablet. IP and BP method, they involve methanol for its estimation. How it is done? Weight tablet powder equivalent to 0.15 gram of tindrazole. 20 ml of methanol is used for and then volume is made up to 100 ml with methanol. So total means what you are taking with methanol is dissolving the tindrazole present in the tablet powder. So then volume is being made up to 100 ml with methanol. Then filtration is done to remove insoluble excipient. From this filtrate, 10 ml filtrate is diluted up to 100 ml with methanol. Okay, and then again from this solution 10 ml is withdrawn and it is diluted up to 100 ml with methanol. Then the absorbance of this solution is noted at 310 nm against methanol. So in the reference covered, there is methanol. In the sample covered, this solution of your drug in methanol. So absorbance is noted, and then how the drug content is calculated. So calculate the content of tinidazole taking 356 as a specific absorbance at 310 nm. So in this way, you may say this method is total method is methanolic method. Methanol is a class 2 harmful organic solvent. Okay, now here in methanol, the peak of tinidazole comes at 310 nm, 310 nm. Okay, now I am replacing this method by hydrotrophic method. In hydrotrophic method, what do we do? Weigh tablet powder equivalent to 50 milligram of tinidazole, add 20 ml of 30% weight by volume aqueous sodium benzoate solution, and shaking is done for 10 minutes in a 25 ml volumetric flask. Again, I am repeating 25 ml volumetric flask, tablet powder containing about 50 milligram of tinidazole, 20 ml of 30% aqueous sodium benzoate solution, shaking for 10 minutes. During this shaking, the sodium benzoate solution, because of its hydrotrophic solubilization function, the drug means tinidazole goes in solution. Then up to the mark means 25 ml. You are going to dilute not with sodium benzoate solution now. Only once you are going to apply 20 ml of sodium benzoate solution. Afterwards, always dilution will be with water. So up to the mark 25 ml, you dilute it with water. Then you have to carry out the filtration to remove insoluble excipient. Then from the filtrate, you will take 1 ml filtrate and it will be diluted up to 100 ml with distilled water. And the absorbance of this solution is noted at 318 nm, 318 nm against reagent blend. I will explain what is this reagent blend. So here in aqueous system, the peak of drug tinidazole comes at 318 nm. In methanol, it was 310 nm. But due to change in solvent, peak has shifted at this at 380 nm. Okay. Now, how to find out the how to make this reagent blend? Reagent blend in this way that you will take a 25 ml neat and clean volumetric flask, 20 ml of 30% weight by volume solution of sodium benzoate you will keep here. Dilution up to the mark with the water up to 25 ml. Then 1 ml of this solution will be diluted up to 100 ml with water. This solution is the reagent blend. This solution contains same concentration of sodium benzoate which is present together with your drug in the sample solution. So this sample solution will be kept in the sample cover and reagent blend solution will be kept in the reagent blend, and then you will note down the absorbance at 318 nm. In this way, the effect of sodium benzoate, because sodium benzoate is in same concentration in both the cover, so there is neutralization of its effect. Now the absorbance is due to your drug only. Okay, you have noted down the absorbance at 318 nm. Now how to calculate the drug content? Now again you will have to do in this way, calculate the content from the absorbance obtained by repeating the whole procedure using 50 milligram tinidazole RS. RS means reference substance, means standard substance in place of tablet powder. So what you will do, suppose we get a sample from some company, it is written on that it contains 99.22% of tinidazole. So based on this drug content, you will weigh out 50 milligram, equivalent 50 milligram of drug tinidazole. You will keep in a 25 ml volumetric flask. You will add 20 ml of 30% sodium benzoate solution. You will shake it, clear solution, then dilution up to the mark 25 ml with water. Again, you will take 1 ml of this solution and dilute it up to 100 ml with water. Now the absorbance of this solution will be taken against the same reagent blend, and then by comparison of these absorbances, you can find out the drug content. This is one way. Another way method may be You may make the television curve of your drug using the standard sample of indazole, 5, 10, 20, 15, 20, 25 mg per ml solution. Respect to reagent blanks you will have to make, and then you will note down the absorbance against the reagent corresponding reagent blank. Then you can plot a television curve, and that television curve can also be implied for drug content calculation and all that. So anyway, now what is the beauty of this method, hydrotrophic method? You have replaced a class 2 harmful organic solvent, methanol, which is there in IPBP method, by sodium benzoate solution. Your method is economic as well as it is free from harmful effects because sodium benzoate is non-volatile. Okay. So in this way, what you are doing, you are employing the solubilizing power of solids to replace harmful organic solvents. In the same way, UV method using hydrotropy, naproxen tablets, IP method involves the use of methanol. Methanol has been replaced by sodium benzoate solution in the same way. One more thing I want to tell you, sodium benzoate does not interfere above 282 nm. Sodium benzoate does not interfere above 282 nm. So you are estimating the drug at 318 nm in tindazole case. So there is no interference, no UV interference of the, in this estimation. Okay. In the same way, naproxen tablet, they are estimated at 331 nm, 331 nm, where there is no interference of sodium benzoate solution. So sodium benzoate solution has replaced methanol. Indomethacin capsule, IPBP method, methanol is used for UV analysis. It has been replaced by sodium benzoate. Of course, here estimation is done at 320 nm, 320 nm. Diazepam capsule, IPBP method, methanol is used. Mixed hydrotropy has been used for its assay. Diazepam is estimated at 354 nm. Okay, now pharmacological method for atenolol tablet and dichloronic sodium, they use methanol, and methanol has been replaced by urea solution. Urea does not interfere above 240 nm. So here in case of atenolol tablet, methanol has been replaced by urea, and measurement is done. Absorbance is noted at 275 nm. In case of dichloronic sodium, urea does not interfere with above 240 nm. There is no UV interference, and the dichloronic sodium is estimated at 276 nm. Like so, there are a large number of compounds have been estimated by UV method throughout the India, and not only India, from abroad also. Now coming to TLC using hydrotropy. Now in short, I will tell you how the TLC can be performed. Now here you will find a reference. One more thing, those who are interested to carry out such type of work, they can connect me, whether you are a student or researcher or teacher, you can associate with me through WhatsApp, and you can call me, you can discuss on phone, you can discuss by email, you can discuss this WhatsApp and so on and so forth. If you are interested, you please note at the end of the lecture. I will do my mobile number and all that, so you can note it down. So here, what I want to say here, this is the complete reference of a published paper. This work has been done by MPharm student in my lab. Now, in short, I would like to tell you 9 water-soluble drugs were used in this TLC work. This TLC work was done without the use of organic solvent, just by using mixed hydrotropy or hydrotropic solution, just by using them as mobile phase. The work was carried out. How this work was carried out? So here, as you are saying, this propanol, hydrochloride, guaifenesin, then in this up to this 9 use water potassium, these 9 water soluble drugs were used in this TLC work. TLC plate was made with silica gel G. Okay, and of course the identification of the spot was done by iodine chamber. And what procedure was adopted? 2% aqueous solutions of these drugs, individual drugs, 9 drugs, 9 individually. 2% aqueous solutions were used to spot the for spotting of the for this drug solution. And after drying of that spot, then TLC plates were developed using 8 blends. MPharm students made 8 blends having different concentrations of hydrotropy within. For example, as you are seeing on this propanol hydrochloride, and of course I told the student to mix. These are the blends which gave a spot without tailing effect. Other blends did not give good spots, means there was tailing in them, so they were not recorded, they were not quoted in this table. But all 8 blends were utilized for each and every drug from these 9 drugs. Okay, so in case of propanol hydrochloride, only one blend was found suitable, that was having 7.5% niacinamide and 7.5% sodium benzoate aqueous solution, and it was used as RF value is 0.80. Okay, iodine chamber for spotting. For character means for identification of the spot and all that. Guaifenesin drug blend 1 containing 5% sodium total was found good. 0.64 similar 5% sodium benzoate plus 5% niacinamide. The same way 1, 2, 3, 7 they were found good spot without tailing effect. In only one blend 6 was found good. Vitamin B hydrochloride, blend 7 was found good. Lidocaine hydrochloride, blend 1, 2, 3, 4, 5, 6, 7. 7 blends were found good like this. In the same way, you are seeing this. So, what is the beauty of this method? That you are performing the TLC without any organic solvent. These are only the aqueous solutions of hydrotrophic agent. Okay, so now you can listen one sentence from me, that for each and every compound, whether your compound is water soluble or your compound is poorly water soluble, for all compounds, for all solutes, you can perform the TLC without the use of any organic solvent, just by using hydrotropy, mixed hydrotropy, or mixed solvents concept. For all compounds, I am saying the word. Okay, now coming to HPLC. This work was done by Remy Madam in Kerala. She means Remy Madam is assistant professor in Kerala University. She is doing PhD. Okay, very soon she is going to submit her thesis and all that. Anyway, this is the published paper of Remy Madam. What she has done here, reverse phase HPLC of cefixime tablet was performed by Remy Madam. What she has implied, 6% bioavailable solution of sodium acetate, adjusting its pH to 6.2 without any organic, no methanol, no acetonitrile, no any organic solvent. Okay, another paper published by Remy Madam is there, where she has analyzed tablets containing 2 drugs simultaneously, paracetamol and dichloromonic sodium, 2 drugs combined. What she has employed? She has employed 5% urea solution as mobile phase, aqueous solution of urea. So in this way, means reverse phase HPLC of compounds can be done using hydrotropy or mixed hydrotropy and mixed solvent concept. But listen one sentence from me. For all water soluble compounds, I am using the word for all water soluble compounds, reverse phase HPLC is possible with the use of hydrotrophic solutions or mixed hydrotrophic solution or mixed solvent concept. I have not added the word for poorly water soluble drug. No. Okay, because there are several limitations using water soluble drug. But for all water soluble compounds, you can use reverse phase HPLC using safe and economic hydrotrophic solutions or mixed hydrotrophic solutions. If you have any query, please note down at the end of the lecture. Now, hydrotropy is about 100 years old concept, but no one has started mixed hydrotropy. But in the year 2008, we have started a mixed hydrotrophic solubilization, means in place of more than one hydrotrophic agent when they are used, then we to the mixed hydrotrophic solubilization. The utility of this mixed hydrotropy is particularly for formulation purpose, because single hydrotropy, the large concentration of single hydrotrophic agent may be toxic, but when you mix hydrotrophic agent in small concentrations and safe concentration, now you can utilize it in formulation. I'm giving one example here. Now you see, this is the list of additives which are employed in intramuscular injection as per Inactive Ingredient Guide 2020. This Inactive Ingredient Guide 2020 books, this book is referred by the pharmaceutical manufacturer to find out the drug additive concentration. So just you see, in these concentrations, these additives are safe, okay, for intramuscular injection. Now you see, number 2, sodium citrate 10% you can utilize in your formulation. Now you see number 8, sodium acetate 10% can be employed. It is also safe. Then you see 13 number, sodium benzoate 10% can be employed. Now, so if you make in place of single 30% weight by volume sodium benzoate solution. If you made a mixed hydrotrophic solution containing 10% sodium benzoate, 10% sodium acetate, 10% sodium citrate. So this 30% solution, this is safe, and if you increase the solubility of your poorly water soluble drug by this mixed hydrotropy, the formulation can be marketed. So mixed hydrotropy can give the marketable formulations. Now the second parameter of mixed solvency concept is, first parameter is that each and everything present in this universe has got solubilizing power. Now second parameter, since you know that each and everything has got solubilizing power, so particularly for pharmaceutical formulations, you should imply the solubilizing power of safe additives. Okay, so just I will give one example firstly, then I will discuss how can you utilize this mixed solvency concept to make innumerable safe solvents. Okay, so first you see this one example before you. Blend has got pH of 7, which blend containing these four solids: sodium benzoate 5%, sodium caprylic 5%, sodium citric 5%, fluoxamine 407 5%. All these are solids. 20% is the total concentration of these four solids. Now pH is 7, which is neutral. And the solubility of several drugs was checked by me in this particular blend, mixed solvent blend, and out of those, I am giving the examples of two only for you. That in case of furosemide, the solubility in this particular blend was 35 milligram per ml, but in water less than 1 milligram per ml. So at least 35-fold solubility enhancement is there because of the solubilizing power of these four solids. Now you should keep in your mind that these four solids, when they are dissolved in water, the molecules of these solids, they are available in liquid state, and these molecules may be involved in hydrogen bonding and weak van der Waals forces with the molecules of furosemide. That's why there's large solubility of furosemide in this particular blend. Okay. Then another example is that of pyroxicam. The solubility of pyroxicam in this particular blend is 20 milligram per ml. Otherwise, in water less than 1 milligram per ml. So anyway, you are seeing this. Of course, there are so many things to say, but time limit is there. I have to finish this by maximum by 10 minutes. So, okay, now the utilization of mixed solvency concept, which I have started in the year 2009. Dry powder injection for reconstitution of poorly water soluble drug candicertan select-cetal. Here is the example. The dose of candicertan select-cetal is 8 milligram. Now, when it is kept with 100 milligram sodium caprylic, 50 milligram sodium benzoate, 50 milligram sodium acetate in a vial, when 1 ml water is added, in the constitution you will get clear solution because of the solubilizing power of these three solids. Of course, the published paper reference is there. Those who are interested, they can see this also. Okay. Now coming to mixed solvency concept, solid dispersion for fast dissolution of poorly water soluble drug. Now here the example is there. Of course, these are the M4 projects. Those who need the soft copy of this thesis, I can send it to you. If you require, you ask me, I can send it the soft copy of all these M4 projects also. So how this solid dispersion was made: furosemide 2.5 gram, poorly water soluble drug, sodium citrate 2.5 gram, sodium acetate 1.25 gram, beta cyclorate 2.5 gram, sodium caprylic 5 gram, and they were dissolved in water. Then drug was dissolved in this, clear solution was there, then water was evaporated out, and after drying you get the solid dispersion. Published paper reference is there. Liquid solid systems can also be developed using mixed solvency concept. Here the example is that of pyroxicam. Propylene glycol is a poor solvent for pyroxicam. The solubility of pyroxicam and propylene glycol is very less than 5 milligram per ml. You cannot make it a liquid solid system using this solubility, poor solubility, no. So we have employed two solids, sodium acetate 10% and sodium caprylic 10%. When they were dissolved in propylene glycol, they increased the solubility of pyroxicam about 24-fold enhancement in solubility was there, 120 milligram per ml. Then it was possible to be converted into a liquid solid system. Aqueous injection can be made. Development of dry powder injection for reconstitution, as I have explained earlier. Now, mixed solvency concept can be used to make innumerable safe solvents. This is very important thing. In pharmaceutical manufacturers, they have got very limited number of safe solvents: water, ethanol, propylene glycol, glycerin, PG400, etc. Very limited number of solvent system. They are sometimes they mix 2, 3, and all that drinks and all that. But when they are handicapped to increase the solubility of drug, now they can have innumerable, I am using the word innumerable, safe solvent system using mixed solvency concept. Now you see example. Now this table was explained earlier also, means this is the safe list of additives which can be employed in intramuscular injection. So I am talking about the intramuscular aqueous injections. Okay. Now you see you can make one blend in this way. Number 1, 2, 3. Ethanol 10%, sodium citrate 10%, arginine 10%. Total became 30%. Okay, so this is one blend. If you replace arginine by histidine, another blend is ready. In this way, by permutation combination, you can have innumerable safe solvent system, because you know that the solubilizing power in each and everything may be having solubilizing power for your drug. So in this way, innumerable safe solvent systems can be made using mixed solvency concept. Design and film has been developed here in MR project. Metronidazole was the drug. Using the mixed solvency concept, the size of film was reduced. Improvement of drug loading in ACDDS using mixed solvency concept. Drug loading in oral film was improved to reduce the size of film. Mixed solvency concept formula for dissolving oral film. All these are the references for published paper. Now extraction of factor constant using solvent system, solid solvent system. Now this is the reference, and this MR project has been done here. Of course, the detail I am not given, but briefly I can tell you. Actually, time is less, but anyway, I would like to finish in 2 minutes because this is the last work we have made. Now in extraction, I want to tell you that solids can also be applied for extraction of factor constant. In brief, I can say you that sesame oil was extracted from sesame seed powder using melted thymol, melted menthol, using their eutectic liquid, using the solution of thymol in ethanol, and so on so forth. They were extracted and they were removed. Okay, so in extraction also there is very this mixed solvency concept is very useful for extraction, and solids can also be employed in extraction. You can replace hexane, and these harmful organic solvent can be their use can be minimized if you can utilize wisely the solids for their solubilizing power. So those who are interested, they can contact me. I will tell you later on, because today I've got very limited time. Okay, now coming to suggestions. Since all compounds possess solubilizing power, we should try to use for excipients, nutraceutical, proteins, amino acids, harmless constraints, fruit and vegetable juices, etc., to enhance the solubility of poorly water-soluble drug, to develop different pharmaceutical dosage forms. Since there are no mathematical formulae for solubility enhancement, hence we have to try them by trial and error methods. Now, a very important information for you. I have made 7 small videos of about, each video is of about 40 to 45 minutes duration. So those who are interested, they can see on YouTube, eco-friendly lecture series 1. If you put these words, then you will find this for UV analysis of drug. So if you put the word eco-friendly lecture series number 2, it is for tight matrix analysis. You can learn yourself at your home. Eco-friendly lecture series number 3 is for mixed solvency concept to understand. Eco-friendly lecture series number 4 is for TLC of compound. Number 5 is for your reverse phase HPLC of compound, and 6 number is for dry powder injection for reconstitution. Those who are who want to take the projects on pharmaceutics field, in pharmaceutics field, they can develop this, they can use this. Eco-friendly lecture series number 7 is to make innumerable eutectic liquids. How can you make innumerable eutectic liquids? You can find the art in this particular video. You will, for what you are going to make a eutectic liquid? For extraction of active constituents from herbal powder, for formulation purpose, for analysis purpose, and so on and so forth, for synthesis of compounds. Now, this is, thank you, slide. So around this, you can note down the WhatsApp number 9406621907. Those whether you are a student or teacher or can join with me. for further research if you want, if you are interested. And of course, email ID is rkmaheshwari@yahoo.co.in. And of course, there is one website also, www.rkmaheshwari.com. And this also so much better on hydrotropy mixed hydrotropy concept is there. So with this, I am finishing my lecture. Now I am coming to you to give the answers for your questions. Madam?
Yes, yes, sir.
Okay. Now the questions.
Yes, yes. Audience, if you have any questions, so ask to sir.
Madam, only 7 participants are being observed here.
No,
Why
sir,
is it?
actually, Facebook page also live.
अच्छा,
Many of join this Facebook.
तो आपने अभी देखा कितने लोगों ने सुना फेसबुक पर, तो आपको पता चल रहा होगा ना?
सर लाइव, हाँ सर लाइव चल रहा है, तो मोस्ट ऑफ देम जॉइन ऑलरेडी जॉइन स्टूडेंट एंड फ्रॉम पीजी स्टूडेंट्स.
नहीं, so, कितने लोग सुन रहे होंगे, आपको पता चल रहा है ये क्या संख्या?
हाँ सर, एक्चुअली वो
लगभग पूछ रहा हूँ मैं.
हाँ हाँ सर.
Okay, madam, question answer.
Yes, yes. So participants, any questions regarding the topics? So ask to sir. Sir, one question. Like organic solvent or this hydrotropy solvent, if we comparison for this in the like during analysis, so how can we compare that percentage or all the things that it is suitable?
So should I talk about the trichromatic analysis or UV analysis?
Yes, yes, yes.
Which one? UV analysis?
Yes, sir. UV.
Okay, UV analysis. Actually, you say I have given the example of tinrazole tablet. Okay, so in case of IPBP method, they are using total methanol. Okay, and here what you are using, once you are using 20%, 20 ml of 30% weight by volume sodium benzoate solution, and further dilution they are always with water. Why it is so? Because when you dilute with water, there is no precipitation of your drug, so you can nicely dilute your solution with water. So now, your method is very cheap. Number one. Now, as you told about the concentration of these solutions, the reason is we can imply 20% sodium benzoate solution also, but here the solubility enhancement is less. More is the concentration of hydrotrophic agent in your solution. More is the solubility of your poorly water soluble drug. So generally, in my research, mostly I have used 30% sodium benzoate solution. Of course, you can make 40% weight by volume solution sodium benzoate also. So here means there's no comparison of a percentage. Means it is not going to hinder any your UV spectrophotometric analysis. Just if you imply 30% sodium benzoate solution, so the drug is easily dissolved during 10 minutes taken. All the drug is dissolved by sodium benzoate solution because of the solubilizing power of this sodium benzoate. This thing should be kept in your mind always. That as I have explained, that all the molecules when they are present in liquid state, they are also capable of hydrogen bonding or making this hydrogen bonding weak bond process with the molecule substance. That's why there is a dissolution of tinrazole. Or means whatever the hydrotropic solubilization examples are there in all that. The solids, particularly, they are dissolved in water and molecules come in liquid state, and they are also involved in bonding and weak bond process. As in case of methanol, for example, what methanol is doing? Water soluble drug is tinrazole, but in methanol it is, methanol is good solvent because the molecules of methanol, they are having good capacity to make the hydrogen bonding at big van der Waals forces with the molecules of tindazole. That's why it's good solvent. In the same way, our sodium benzoate solution is also good solvent for this tindazole. Methanol is not interfering in your UV analysis. In the same way, sodium benzoate does not interfere above 292 Nm. But methanol is can be used for a long, for a broad, you may say nanometer wavelength. But in case of sodium benzoate, you should not estimate the drug before 292. Okay, 292 above. For example, in case of tindazole at 318 Nm, there is no interference of sodium benzoate. Similarly, another hydrotrophic is niacinamide. It also does not interfere above 292 Nm. Means that can also be employed for tindazole tablet estimation. Anyway, so in this way, means this concentration importance is only just for dissolution of your compound and for the dilution with water.
Okay, sir. Okay.
Madam, are you from chemistry? Quality assurance.
Yes, yes, sir. QA department.
So please carry out such types of work because they have got objective that without organic solvent you are going to.
Yes, yes.
And of course, these patents can be granted for HPLC to carry out HPLC, but they should try particularly in starting they should take water soluble compound in reverse phase HPLC I am talking about, because a small concentration of hydrotrophic agent can be implied to act as mobile phase, but concentrated solutions cannot be implied because the column may get choked like this. So water soluble compounds should be selected. Of course, some persons they are carrying out, and of course they will get a patent also. I know. So these things should be utilized so that you can minimize the use of methanol, acetonitrile, and so on and so forth.
Yes, sir. Yes.
You see, madam, actually what happened? The analytical chemists, they are paid for doing the analysis. Okay,
Yes.
they are getting salary. Suppose some analytical chemists, they are routinely is performing HPLC, and sometimes the methanol, sometimes acetonitrile, they are being involved. Okay, so can we reduce this? Can we minimize the use of such types of organic solvent so that the human being is prevented against the harmful effects of these vapors of these harmful organic solvents? One more thing I would like to mention here, which you see very recently a book has been written by foreign author, by authors of about 9-10 countries, including India, France, this South of Egypt, and they have made, they have edited a book on green pharmacy, green chemistry. Okay, in that one chapter, chapter number 6 is on UV and titrimetry analysis using green hydrotrophic method. I have done such a large work, and of course, so many persons in India, and not only India, from abroad also, they have done such a voluminous work that 4 authors abroad, means foreign authors from Saudi Arabia, Egypt, and Japan, they have written a chapter. And of course, this is a chapter. I will send a book to you, is a soft copy, of course. You see that why they have written. I have not written that book, but I am very happy to see this chapter in this Springer book, because now the work will be tremendously is promoted in this way, like this. And of course, a day will come when such analysis, hydrotrophic analysis, will come in your syllabus books, in pharmacopoeias, and so on and so forth. And not only in titrimetry, not only in UV, but also in TLC, HPLC, mixed solvency concept, mixed hydrotrophic. Means so many chapters will be written now, like this.
Yes, sir. Yes. Thank you, sir, for sharing your valuable and information, knowledge, and time with us. Actually, this is a very broad topic to all this basic approach of hydrotropy solubilization applications in analytical techniques like UV, HPLC, HPTMC with examples. Sir has covered mixed solvency concept of this approach very nicely. So I hope all the participants must have benefit from your talk, especially those who are involved in the researchers, like beginners. So on behalf of Parul University, Sir, kindly accept that e-certificate as token of love and gratitude. Just a minute, sir.
Okay, thank you, madam. Thank you.
Thank you so much, sir. Kindly accept this.
Okay, okay, thank you.
Okay, thank you, sir.
May I leave now?
Yes, sir. Yes, sir.
Malu di connect.